Hi, I am Dr. Mohanty. So today we will discuss about the valve timing diagram. So before discussing the actual valve timing diagram, first of all we should discuss what is the theoretical valve timing diagram. Theoretically, the inlet or suction valve is opened at the top dead center position and is closed at the bottom dead center position. Similarly, the exhaust valve is opened at the bottom dead center position and is closed at the top dead center position. But in actual case, valves are never opened at dead centers. That means the inlet valve is opened few degrees before the top dead center position. Similarly, the exhaust valve is opened few degrees before the bottom dead center position. Similarly, when it comes to the closure of the valves, the inlet valve is closed few degrees after the bottom dead center position and the exhaust valve is closed few degrees after the top dead center position. So now what we will analyze is that why this is happening and what are the advantages of having this system in place, and then how it affects the performance of the engine. Now we are having two categories of engines. One is slow speed engine, the second one is high speed engine. Subsequently we will discuss that why there are variations in opening and closing as far as the angles are concerned. First of all, we should know that whenever we open the valve, it takes some finite time to open up. So for that reason, the inlet valve is opened few degrees before the top dead center position, so that by the time it reaches the top dead center position, it would be completely in open position. Similarly, even if you close the inlet valve at the bottom dead center position, by the time it is completely closed, it would have covered some angle. So for all practical purposes, the valves are opened before the dead centers and are closed after the dead centers. The same is true about the exhaust valves also. Exhaust valves also take some finite amount of time in opening. So even if you open it few degrees before that, it would only be opened at the bottom dead center position because it takes some time in opening. The same is about the closure also. Even if you start the closure at the top dead center position, it would take some time to be completely in closed position. So if we restrict its opening and closing at the dead centers, we will not have complete admission of the charge into the system. Now, what we will analyze that there are variations in the angles which are given. That means the angle that is at which the inlet valve opens in case of your slow speed engine is different from that of the high speed engine. So why such variations are taking place? First of all, we should know that whenever the valve is opened and the charge is admitted into the system, due to inertia, some more amount of charge will be drawn into the system during the compression process also. Usually it is expected that due to compression, as the piston moves from bottom dead center position to top dead center position, it is expected that the charge would be compressed, but due to inertia during some part of the compression stroke also, some amount of charge is drawn into the system. In case of slow speed engines, the speed at which the charge actually enters is less, so inertia is less. So for that reason, it is open only few degrees after the bottom dead center position. It cannot remain in open position beyond that, because otherwise what would happen, there would be backflow of the charge. That means the charge which is in the engine cylinder would leave the engine cylinder. But when it comes to the high speed engines, the speed at which the charge is admitted into the system is very high. So the inertia is also high, and due to that what would happen, that for a considerable amount of time you will have the admission of the charge taking place into the system, even if the piston is moving from bottom dead center position to top dead center position. So you can see the variation in angles. Here it is only 10 degree, here it is 60 degree. That means in case of your slow speed engines, the inlet valve is closed 10 degrees after the bottom dead center position, whereas in this case it is as high as 60 degree, and that is very important for us to remember. The same is true about the exhaust valves also. That means whenever you open the exhaust valve, here it is opened only 25 degrees before the bottom dead center position, and here it is opened 55 degrees before the bottom dead center position. Similarly, here also it is closed 5 degrees after the top dead center position, where it is closed 25 degrees after the top dead center position. So why these things are happening? Because in that case also, due to inertia, some amount of bond air fuel mixture will leave the system even after the completion of the exhaust stroke also. But what happens that when that is very high, then there is a probability of backflow. That means some amount of exhaust gas will leave simultaneously with some of the fresh charges. That we do not want. In any case, our basic objective is that we must have maximum admission of charge into the system so that more power can be developed, and we do not want the backflow of the fresh charge, and also we do not want any loss due to this. So for that reason, we must take care that we have adequate admission of the fresh charge into the system, and none of the fresh charge leaves without being ignited. Another important thing that we need to remember, that there is a particular speed at which the engine must run, whether it is a slow speed engine or a high speed engine, because beyond certain speed the amount of charge that is to be admitted will be less. Take the case of slow speed engine. In case of slow speed engine, what actually happens, that if you run it at a very high speed, that means if the RPM is very high, what actually happens, very less time is available for intake to take place. That also affects the intake air quantity or intake mass of the charge. The same is true about the high speed engines. In high speed engines, what actually happens, in some cases that the fluid friction actually obstructs that. So the inertia factor, which actually helps in allowing more amount of charge to enter into the system, that advantage no longer exists. That is being counteracted by fluid friction, which actually restricts the flow of the charge into the system. But in both the cases, our basic objective is to ensure that sufficient quantity of the charge is allowed to enter into the system so that we can develop more work output.